Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing strings topic and following two pointers pattern. In this we will do the last question, which is palindromic substring. So let's read the problem statement. It says we will be given a string and we have to return the number of palindromic substrings in it. And palindrome means, you know, when we read a string from front side or back side, we read the same way. And substring is a continuous part of a string, means we cannot pick any characters from any location. We have to pick characters in a continuous manner only. Now let's read the constraint. We can see the constraint can be from 1 to 1000. Okay. And why we read the constraint? Because it helps us to optimize our code and apply the valid pattern on that. Okay. So let's come on to the screen. And here you can see that we have a string AAA, and we have to say ki how many such valid number of palindromes are there. So if you see, this alone simple A also makes one palindrome, another A also makes one palindrome, another A also makes one palindrome. Again, AA is also a substring. You can see the 0th and 1st character. So hence next AA also, which one? 1st and 2nd character, and now all AAA. So if you see, there are 6 substrings in the string and all are a valid palindrome. So you have to return the count of this, which is nothing but 6. Okay. So if you are following my playlist one by one, then you know that we have solved this similar question earlier, which is longest palindromic substring. And there we have to find the longest valid substring out of all the substrings in the string, and here we have to count all such. So earlier when we were sending all substrings, and in the function we were checking if this is a palindrome or not. If it is a palindrome, then we were checking that is the maximum length or not. If it is, then we were updating. But here in this case, we will simply send the substring one time A, next time AA, next time AAA, and so on. And if all such substrings are valid, we will simply increment the count. Don't you think so? Yes. So basically, I won't spend much time on rewriting the code again. Okay. We have already discussed a function called palindrome check. In this, we were sending the substring. Okay. And then we were checking if it is a valid palindrome or not. Okay. If it is a valid palindrome or not. Okay. So here we are sending the substring. So basically out of this string, we have to select that substring part, and then only we have to call this palindrome check. And if this function returns true, then we will count. So basically to hold all substrings, we were running two for loops. For int I is equal to 0, I less than s dot length, and I plus plus, if you remember. Yes. So basically, if I am pointing my I here, so I want every such substring which starts with I index. So if my I is here, I will initialize my J index, and from I to J means simple A, I will consider this as a substring, and then I'll call this palindrome function check. Okay. Next time J will move to this pointer, and now I want from I to J means this AA. So now this next time this AA will go in the function called palindrome check, and it will check if this is a valid palindrome or not. Whenever the function returns true, we will count somewhere here. Okay. So to get the substrings, definitely I have to initialize a substring, substring here, correct? And now I want to call, I want to make another for loop where J starts from I, and I want my J to run till s dot length definitely, and J plus plus. And from I to J is my substring, correct? So I can do this way, or else in the substring only I can keep on adding this s dot caret J, correct? So one by one in my substring sub, I'll keep on adding the character at jth location. Yes. After adding every time, sub is something which holds a substring. So for first, from I is equal to 0 to j is equal to 0 only, sub will have only A. Next time it will have AA. Next time it will have AAA. So for every sub, I want to check if it is a palindrome or not, correct? So I'll call this palindrome check function here. Palindrome check function here. Yes. And I'll send this sub. If it is a valid palindrome, means if this function returns true, so I just simply need to increment the count. So for that, I will initialize a count variable somewhere here, and at the end I'll simply return my count. Yes, very simple. But the time complexity, if you'll see now, because we are running these 2 for loops to calculate each substring, okay, so it will take O of n square because it is nested, and inside this only we are calling this palindrome check function, and here we will apply the 2-pointer logic. If you know why 2-pointer logic, because to check any character, any string, if it is a palindrome or not, we start a left pointer and right pointer from the end, and these left and right pointer we have to check if these are same or not. But 2-pointer to only we apply when it is sorted. Not such. Basically 2-pointer we can apply if it is sorted, means we can decide where to move our left pointer and right pointer. But in the string, even if it is not sorted, but if we can decide here where to move which pointer on what condition, still we can apply 2-pointer. So here what we are doing, whenever my left and right pointer are matching, definitely I know these this first and last character matched, so I want to match my second and second last character. So for that I know where to move my left and right pointer, and hence I can apply my 2-pointer approach. So here basically we are running this left and right pointer until they touch or crosses each other. So hence can I say O of n by 2 times I am running this for loop, correct? So total O of n square for this substring generation, and another nested n by 2 for this palindrome check function. So in total n square into n by 2, which is somewhere near around n cube by 2. Okay. So if my 10 power 3, n constraint is 10 power 3, so n cube will become definitely 3 plus 3 plus 3 means 10 power 9 divide by 2. You know, beyond 10 power 9, like beyond 10 power 8, sometimes it gives us daily. But till 5 into 10 power 8 or 6 into 10 power 8, it might be safe depending upon the logic we have written in our code, correct? Sometimes 10 power 7 or 8 can also give us daily. Again saying logic matters, but here the logic is very simple. So definitely a simple character checking, first character matches with last character or not, it is very simple execution, so it won't take much time. So hence in this case 5 into 10 power 8 will also be safer. Why I am saying this 5 into 10 power 8? Because n is 1000. Okay, so this will take n square, means can I say 10 power 6? Yes, definitely. Now I am saying this, if this is 1000, definitely it is running for n by 2 times. Okay. So to be more precise, 500. So if you multiply this 5 into 100 means 10 power 2. So in total it will be 5 into 10 power 8. Okay. Okay. And the worst case, it won't even touch that also. So it might give you TLE, or else it will be very slow. But as you know, this is a brute force approach and we need to optimize this, and the similar logic we have discussed in the previous question also, which is longest palindromic substring. There also we discuss the brute force approach and how to optimize this. Definitely this palindrome check function, where we want to check every substring is a palindrome or not, that we cannot reduce, but definitely the substring generation function we can reduce, where instead of using 2 for loops, we can do in a single for loop also. And how we did that with odd and even palindrome check we already discussed. So I will definitely recommend you all to check that video first and then come here, and trust me, if you will see that video, then this video you can do on your own also. So here is a brute force code we have discussed. We have to count, so we will initialize the count variable and we will run 2 for loops to generate the substrings. First for loop will run from 0 to n, and second for loop will definitely run for I till n. So here in this function, you can either send the substring after generating and then check if it is a palindrome or not in this function, or else you know to check the palindrome, anyhow we are using the left and right pointer itself. So you can send the entire string also, but this I and j will take care of checking the palindrome condition from that pointer only, means left to right. Okay, what I said, let's see. I said if A, B, A, C is a palindrome, okay, like A, B only, okay. So I am saying even if it is long, but I want to check from this to this if it is a palindrome or not. So even the function I send the entire S, A, B, C, okay. But I send the I and J till here, means 0, 1, 2, 3, 4. Means from 1 to 3 only I sent, na. So anyhow my I and J will check the palindromic condition only for this much string, like substring B, A, B, correct? Why? Because if you see here in this while loop, we are running the while left and right crosses each other, and in this we are doing left plus plus and right minus minus until they are same. So here what we are doing, left is nothing but I and right is nothing but this, we will match this, and then we are doing left plus plus means here and right minus minus means here, means we are shrinking. So anyhow we are actually checking in this substring only. So we can either send the entire BAB as a substring to check, or else we can send the entire string but with this left and right pointer which is ij till where we want to check the palindrome or not. Okay, so we'll do that here, and if it is a palindrome, we'll return true, and whenever this function returns true, yes, that substring is a palindrome, we'll just do the count plus plus, and at the end we'll return the count, because anyhow the question asks us to return the count of such valid substrings. So now we can run this code, and anyhow the total time complexity will be O of n square multiplied by n by 2. This can either get submitted or else it can even give you TLE as well. But as you know, it has been submitted. The reason I have already discussed, I told you in this video only, and as you know, if either it has been submitted but the complexity is very, very slow because it is near about n cube. Yes. Okay, now so how can we optimize this? I have already taught you in the previous video. I hope you would have watched that out till now. So following that, this is how we did in the earlier video. We have to count, basically we have to call for that ith index, considering that ith index is a part of odd length palindrome. Next time, considering that this ith index is a part of even length palindrome, and here when inside the expand function, why this expand function, reason is already been discussed in the previous video, again saying, because I won't take further 10 minutes to discuss this again, which I have already discussed there. So this left and right pointer will consider here, and here instead of shrinking, because if you know in the palindrome we shrink, correct, here we will expand. Okay, and as per the expansion only we'll calculate, check every length left and right pointer, if they're matching, then again we'll expand further, again expand further, and for expanding left minus minus and right plus plus we do. Now meanwhile we will keep on adding the count as well. Okay, why I said this? Suppose this is my string, okay, S. So first time I will be at here, correct? Yes. So now I want odd length palindrome. So definitely when I want odd length palindrome, so my I will point here, and next time for odd length, definitely I want I minus 1 and I plus 1 to be matched if it is a odd length, because you know center won't match with anything else, it will match with itself in only. Yes. So in this case, when my I will be here, I minus 1, I plus 1, I plus 1 is so there, but I minus 1 is not valid. So hence odd length palindrome check at I is equal to 0 will stop here only, correct? So for this only we would have called the function, and this function would have matched it with itself, and then we would have done count plus plus, correct? Yes, here you can I'm again showing this code. What I did, here when I is 0, I will call the function, correct, in the left, I and j is nothing but left and right, okay, and while, because it is expansion phase, so because left we are doing left minus minus, so it might go beyond 0 and it can be negative. Similarly right can go beyond the length and it can be more than length. So hence we have to stop, write the stopping condition here, and we have to keep on checking if my left pointer and right pointer are matching or not. So similarly if my, I am checking for the odd length, so I will be my left pointer only and I will be my right pointer also. So hence when my I left and right matching, so can I say it is a valid palindrome? Yes. So hence can I consider this counting as one valid palindrome? That's what we are doing here, count plus plus. Okay. Next time when we'll do left minus minus and right plus plus, left minus minus is not valid, and hence the while loop will stop. Okay. So can I say when my I was 0, total count was 1, and anyhow it is 1 only, because till now what do you think, how many such valid substrings needs to be there? Of course 1. Now this was for odd, but what about even? If my I is at 0, definitely it needs to be compared with this I plus 1. Can I say this? Because for even, this needs to be compared, this needs to be compared, correct? Yes. So hence when my I is 0, if you see here in my even length function, let's call it odd length function, and let's call this even length function, correct? So for this even length, if you see, left pointer I am sending this as I, and right pointer I am sending this as I plus 1. Okay. So definitely can I say ki this right, this is left. Okay. and this is my I only. So when my I is at 0 only, for odd length I have counted count 1, and for even length if I'll say left and right both are valid, both are matching, so again I'll do 1 count plus plus, yes. So now this count will become 2, yes. Now for the next one, right plus plus, right will come here, and left minus minus, left will come here, and as left is not valid, so hence it will stop here. Okay, so can I say for I is equal to 0, odd length gave me count 1 and even length also gave me count 1. Okay, now let's move this I at I is equal to 1, and now let's see again for odd palindrome and for even palindrome. Okay, so if my I is at first index, so for odd length palindrome definitely my left pointer will also be I and my right pointer will also be I. Okay, hence it is valid, so we will count this. Okay, so for I is equal to 1, count will again be 1 for odd I am saying. Okay, next time because left and right are here, so for next time left we do minus minus and right we do plus plus, as they are valid, correct, and they are matching. So can I say it is valid? So again one more time count plus plus. What is that? First time to A and next time A. Yes, it is valid. Again it will be count 2. Okay, next time again left minus minus, right plus plus, but now this time both are not valid. So now I can say stop. Now for even length, if my I is at 1, now let's see for even. For odd we have checked, for odd we got A and A. Now for even, if my I will be at here, so definitely left will be here and right will be here. So now we'll send this, and definitely in the palindrome check function it will say yes, it is a palindrome, so we'll do count plus plus again. So now total count will become 3. Now we'll move this I ahead for this, and now we want like I is equal to 2 for odd length. Okay, so now for odd length we will initialize count with 0 definitely. Odd length will say ki left also this, right also this, obviously this match, so count will become 1, count will become 1. Next time left will be at here, like left minus minus, and again right plus plus. Now because this right is not valid, so we'll stop. So for I is equal to 2, odd length has given me count is equal to 1. Now for I is equal to 2, even length, for even length definitely left will stay here, but right we always start from I plus 1, and that is not valid, so hence in this case we won't count anything. So in total if you see 2 plus 3 plus 1, which is nothing but 6, so in total we got 6 such valid palindrome substrings. Okay, but let's see the time complexity. If you can see, instead of using 2 for loops, now we are doing this in just 1 for loop, and here expand function is nothing but actually instead of shrinking and then checking it is a valid palindrome or not, in this like optimized way we are doing this like palindrome check while expanding. That also we can do, right? So hence it still takes O of n by 2 only, and the upper one is taking O of n, which is somehow O of n square only, which is far more better and optimized way. Now we can submit this. Let's try to submit this as well, and I hope you guys understood, and again I'm expecting you would have checked the previous solution as well and you understood this one. So as it has been submitted, so this was your Java solution, and here is your Python code with the similar logic, only the language differs if you are from Python background, and here is your C++ code if in case you are from C++ background. So I hope the logic you understood, both the brute force and optimize. So with this we can go in our sheet and we can mark the last question also submitted, and I hope you will also mark that only after submitting on your own. Again saying, don't just copy paste the solution, try submitting and writing the code on your own, make your proper notes, because anyhow at the end while revising it, only notes will be your best friend. So that's it guys, I hope you understood. If yes, do let me know in the comment section, like commenting submitted or understood, because that gives me more motivation to make more such videos for you all. And please don't hesitate to share the channel to your friends if you find this channel really helpful. And if in case you guys are new to this channel, we are following the pattern wise DSS sheet. The link of the DSS sheet and all social media links will be there in the description if in case you want to connect with me and want any kind of guidance. And that's it. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family.